Okay, in this video I'm going to be looking at the electrophilic substitution of benzene. For standard level, all you need to know is the reaction equation. So benzene reacts with nitric acid in the presence of a sulfuric acid catalyst to form nitrobenzene and water. For the higher levels, you need to know the entire mechanism for this reaction, and in addition you also need to know how the electrophile is produced in the first place. So an electrophile is a species which is attracted to a negative charge center. In this case, the negative charge center will be the ring of delocalized electrons in the benzene. The electrophile is often a positively charged species, and in this case the electrophile will be the NO2 plus ion. And the way in which the NO2 plus ion is generated is that the nitric acid reacts with the sulfuric acid, and these are both strong acids. However, the sulfuric acid is a stronger acid than the nitric acid. So in this reaction, the sulfuric acid donates a proton to the nitric acid, therefore making the nitric acid act as a base, and the nitric acid accepts that proton to form H2NO3+. And the hydrogen sulfate ion. So the H2NO3+ molecule is the conjugate acid of the nitric acid, while the hydrogen sulfate ion is the conjugate base of the sulfuric acid. So that's the first step in the process of producing the electrophile. The second step involves the H2NO3+ decomposing into water and the NO2 plus ion, and this is the species that will be the electrophile. So we now have the electrophile. So the mechanism itself for the production of nitrobenzene involves the electrophile attracting a pair of electrons out from the ring of delocalized electrons in the benzene. So we can draw a curly arrow showing the pair of electrons moving out of the ring on towards the electrophile, and this will produce an intermediate where one of the carbons still retains its hydrogen but is now also bonded to the NO2. The positive charge is now transferred into the ring and will be delocalized around that ring. Now this is unstable, and the molecule will seek to draw a pair of electrons back into the ring, and it will do this by taking electrons from the bond between the carbon and the hydrogen, therefore breaking this bond and letting the hydrogen leave as an H plus ion. So the product that we now obtain is our nitrobenzene and an H plus ion. Now this H plus ion will rejoin the hydrogen sulfate ion which we produced above, and therefore will regenerate the sulfuric acid, which is therefore acting as a catalyst in this process. It's not consumed. So the production of nitrobenzene follows this electrophilic substitution mechanism. In addition to this, you should also be familiar with how nitrobenzene, NO2, this molecule here, can be converted into phenylamine, and this is actually a two-step process. The nitrobenzene molecule can be reduced. The reducing agent in this case is actually going to be hydrochloric acid, and it does this in the presence of a tin catalyst. So this reaction here will remove the two oxygen atoms and replace them with hydrogen atoms, forming the phenyl ammonium ion, and in addition to this, water. Since we had two oxygen atoms, we need to form two water molecules, and there will be two hydrogen atoms being added into the molecule. Now this is reduction, as we are removing oxygen and we are adding hydrogen to this molecule. So this is the first step of the process, taking place in the presence of concentrated hydrochloric acid and a tin catalyst. The second step of this process involves removing the excess proton in the phenyl ammonium ion using a strong base so for example sodium hydroxide or potassium hydroxide, and this will remove one of these protons, producing our final product, phenylamine and water. Okay, so here we have the electrophilic substitution of benzene to make nitrobenzene, and then the reduction of nitrobenzene to make phenylamine.